Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video for you. All math-based, of course, and welcome back. It's an honor and a privilege to have you learn some math with me. What am I watching? Watching an Arby's commercial. No, it's Monday Night Football, back to Raiders and Broncos. If you just saw my last video on combining like terms, then you know I'm just continuing on. Same outfit, I'm not trying to be really different. So what's today's thing about? We're solving some proportion equations. I got, I think, 12 practice problems for you to do. If you want to learn a little bit more on the proportion idea and exercises and stuff, I do have a lecture video on that. It's about 40 minutes long, and to be honest, only the last 20 minutes or so would be actually useful for you in a math classroom, but you'll probably hear some more things there. I'm actually going to be using the phrase cross multiply a lot here. Now I want you to know, full disclosure right now, math teachers, especially myself, we're not really a big fan of teaching cross multiplication without getting you to know what it means. And I do use a part of that video to really talk about what cross multiplication is, because there's really something else that's going on. Cross multiplication is really like a magic act kind of action that's done. It's not a real math thing, but there's math behind what's happening that always lets it work. So I'll be doing cross multiplying in here. I'll show you some other tips and tricks along the way to make things work out. It's kind of cool how proportions can flip and do things like that. 2-word problems at the end, I think, and we'll get it taken care of. Once you kind of solved one, you've kind of solved them all. There are some with different quantities. I think I've said my stuff enough. Let's go and go to the problems, shall we? So I'm going to do all the problems here. None are circled, which means I do all of them. Let's go in order here, starting with number 1. I got 4 over v equals 2 over 5. Now, as far as a proportion, just so you're aware, are two fractions set equal to each other. And we're trying to find the answer to the variable. What variable? What value makes this true? So with some of the problems, you're going to find some obviousness to it. So why don't we just do this one in an obvious way? 4 divided by some number equals 2 divided by some number. Even if you don't know what that value is, proportions can also work in a growth sense. And this is why word problems are helpful. This could be something like if you eat 2 pizzas in 5 minutes, 2 pizza slices in 5 minutes, then you would eat 4 pizza slices in how many minutes? That's the proportion idea. So I could just say, well, if I double 2, I get 4. So if I double 5, I'll get my answer right here. And you're not wrong. That's actually what you can do. And that's something that I want you to look to each time. So case in point, look, I'm just going to solve this one in this way. V equals 10. There it is. 4 divided by 10 is the same thing as 2 divided by 5. We'll find easy ways to solve easy problems and different ways like cross multiplication to solve less easy problems. Okay, number 2. N divided by 5 equals 2 divided by 3. N fifths equals 2/3. This one not so easy this time. 3 times what gives you 5? Even if you know that answer, I think it's just safer and better to go a different route on this one. Let's do cross multiplication this time. And this is what it looks like. 5 is going to multiply with 2, and 3 is going to multiply with n. I get 3 times n, or 3n, equals 5 times 2, which is 10. Okay. So that's the cross multiplication action. The objective, just so you're aware, for cross multiplication is to rid your fractions. That's the end, hope, and goal. It makes things a lot easier for us to work with, and things we're common with seeing. Divide both sides by 3 right here, and you get n equals 10/3. Now I'm going to leave the answer like this. I want to make another statement about a problem like this. Let's just do it with this one here. Let's ignore cross multiplication and take a look a little bit less about it being a proportion and look more like it saying I'm taking n, dividing it by 5, and I get this number. I don't care that the number's a fraction or not, but I divide by 5 and I get this number. If you divide by 5 to get a number, you can multiply both sides by 5 to get your result. I don't have to cross multiply. N's dividing by 5, I multiply both sides by 5, and I can still get my 10/3 result there too. It depends on if your variable's in the numerator or not. Okay, it depends on if your variable's in the numerator or not. Like number 4, I couldn't just divide both sides by 7 and be good, because x is in the denominator here. Okay, number 3. Now before I go about, again, doing just cross multiplication, make a problem easier for you if it helps. For example, 8 over 4 right here can reduce. 8 over 4 can reduce to 2. So 8v divided by 4 is 2v, like this. 2 times v equals 5/3. Now, some people might say, hey, let's divide both sides by 2. But you might run into personal perceptual trouble and say, well, I know how to divide 2 by 2, but I don't know how to divide 5/3 by 2. There are other ways you can divide by 2, like multiply by 1/2. You can multiply by the reciprocal there. That's a good option. That'll work out. You just multiply across, not the same as cross multiply. But what most people would prefer to do, no matter what, most people prefer to say, I'd rather write this as 2v over 1. That way I can cross multiply. See, it's one of those things that I encourage you to look at a problem any which way that you feel comfortable, but I don't want you to stick to one and just say, this is all I can do. You got to know how each problem is evolved and see how many different ways you can do it. Regardless, you can do this, so let's cross multiply. Now, why did I reduce it? To get smaller numbers. Why not? I get the same answer. So 1 times 5 is 5. 3 times 2v is 6. So 6v. So 5 equals 6v. Divide both sides by 6, you get v equals 5 over 6. I'm not going to double check these answers for you here. We're just going to go swimmingly along. I want this video to be shorter, but I do want you to see a lot of different approaches as I go. All right, number 4, like I said, I can't just divide both sides by 7. That doesn't get x by itself in the numerator. It only gets it by itself in the denominator, and that's not enough for an answer. So I would recommend cross multiplying. But before it, again, 2/8 can reduce. It can reduce to 1/4. Just like last time, 8 over 4 could reduce to 2 over 1. So 2/8, I'm going to reduce it to 1 over 4 first. Is this required? No. But if you get an answer that has a fraction that's not yet reduced, it is required that you reduce that portion then. You want your simplest possible form of an answer, one that is accepted by all. And this is a good way to start it. If there's a fraction to reduce, do it early. Okay, so cross multiply right here. And again, you need to do it in this case in the sense that x needs to get in the numerator. So you might as well do it here. And this will solve it. X goes up right here with 1. 1x is x. And 4 times 7 is 28. X equals 28. 7/28 equals 1/4. Yeah, it reduces to that. That's actually true. That's cool. Okay, number 5. Now, number 5, we can look to reduce again, and I will. We got 8/12 right here. That reduces, these can both divide by 4. So that reduces to 2/3. So I have 12 over m equals 2 over 3. Now, 2/3 can't reduce anymore, and clearly 12 over m cannot reduce. However, here's something else about about proportions that I want you to know. And I'm going to write on the side, it's going to be a debrief, and then I'm going to bring you back, just to make sure you understand why I'm doing this and what I can do with it. When we first saw proportions, if you saw from my previous video, you can see it like this. And when you cross multiply, you get a times d equals b times c. See if that makes sense. See if you can believe me with that idea. And on that notion, here's your A and B and C and D. Okay? Or, we reduce them. Let me write them here. A, B, C, and D. Now, what I'm going to do here is I'm going to rewrite these. I'm going to rewrite these in a different way. See if you can follow along with this. Instead of having B and D in the denominator, and I'm not saying let's have A and C in the denominator, let's mix things up a bit. What if I divide both sides by C? Okay. And then what if I divide both sides by D again? So by C and by D right here. C's cancel on this side, D's cancel, become 1. Become 1 on this side. Now I have A over C equals B over D. Now why did I write that? Well, for one, I'm allowed to. You might know the baby pebble man boulder example that I gave in my lecture video thing. I can do baby man pebble boulder as well. I can point to them a lot of different ways. Why does this matter? Because what if I rewrite this one over here with A over C and B over D? A is 12. Check this out. A is 12. C is 2. B is M. I just wrote a C. C is 2. B is M. D is 3. Why does this matter? Because 12 over 2 can reduce. Now, you didn't see this before. Look at this. I couldn't do it before. But 12 over 2 can reduce. That can reduce to 6 over 1. Same kind of way. You know what? I'm just going to leave it as 6. I'm going to leave it as 6 because I want you to try this in different ways. Equals m over 3. And I multiply both sides by 3 from there. You know what I mean? Because m divided by a number is 6. That number must have been 3 times larger. So you'll get m equals 18. Now, looking back at this again, I rewrote it from here into here, a different way of writing that same proportion with different fractions because it can reduce. There's more than one way to go about doing this, and you don't have to rewrite it as a different fraction to make it happen. What's kind of cool, and I hope we run into another problem like it, we might not. So what's kind of cool about this is, look at this 2 and this 12 right here. These can both reduce together because you multiply 12 by 6 to get 2, just like just like if I reduce this to 1 and 6, you multiply 1 by 6 to get 6. I said 12 by 6 to get 2. You multiply 2 by 6 to get 12, just like you multiply 1 by 6 to get 6. You can reduce straight on top or straight on bottom as well. There's a math reason behind it. I'm really dividing both sides by 2 in my equation. But rewriting it as a fraction might give you that idea, but at least it gives you acceptance of it. You can accept the fact that if I do this rewrite, then it's actually a possible thing. Now that was a lot of work to get something reduced just half as much, and I'm sure you could have done 3 times 12 and all that. But it depends on how big the numbers are. And the bigger the numbers are, the more you'd be willing to do it. Are these numbers going to be big on this sheet? I guess not. Not too big. But I'm giving you every single possible outlet that you can. The point of these practice problems is still to teach you about proportions in any way that I hadn't before, or in a way that I can give light to that I wasn't able to before. Okay, so same with a problem like this. Again, 6 divided by 2 is 3. I'm going to straight up write 3, and the reason why I'm not writing 3 over 1 is all I have to do now is multiply both sides by 5. This worksheet did not say solve using cross multiplication. This worksheet said solve. And I'm going to solve it in any way that I see best fits my needs. And in this case here, it would be like that. That's the algebraic approach. Do you have to do it that way? Absolutely not. But you are seeing a lot of different outlets and how these problems can work. I'm going to always recommend you reduce fractions, though, if it comes to something very simple, because it can make your number smaller, and that is important. Okay. All right, the last 4 problems here before I dive into the word problems on the next page all involve an extra quantity. Now, to do the extra quantity, you have to look at distribution. Because x minus 2 is grouped, it's grouped. It's like there are parentheses there. It's implied that they're there. So you might as well think like they are. Okay. Now, I could cross multiply to begin with, but again, I'm going to reduce. 2 over 6 reduces to 1/3. Okay, so I get 8 over x minus 2 equals 1 over 3. All right, how's that game go? I don't know the score. We'll check it out in a bit. Cross multiply. 8 is going to multiply by 3, and 1 is going to multiply by x minus 2. Notice how even though 1 is not going to change my result when I do this distribution, I'm writing it this way so you're aware of what it looks like in case I need to do it again, don't need to do it again, whatever. All right, so I'm just making sure you understand. 1 would distribute into here, but of course 1 times x is x, and 1 times negative 2 is negative 2. So 24 equals x minus 2. Add 2 to both sides. You get x equals 26. More than one way to do these problems, of course, like I said, but I'm going to do fraction reduction whenever I can. No reason for me not to. There really isn't. So I shall. All right. Next problem here. Again, can I reduce a fraction? Heck yeah! This becomes 2 over 8 becomes 1 over 4. And I have n plus 1 over 4. Now, there are 2 different interesting ways to look at this. Number 1 is the way that I talked about before. I can also work right to left and say, can I reduce these things as if they were a fraction? And the answer is yes. 4 and 4 can both reduce to 1 together if I'd like to. Like, hey, these reduce to 1 over 1, like that. Just like I did on that problem number, I think 5. Okay? That's one way I can look at this, which there's nothing wrong with that. Here's the other way I can look at this, though, and it's going to give you the same thing. Look at the fact that these are both dividing by 4. Now, I want you to think about this. If something divided by 4 equals something else divided by 4, the only way that's true is if these 2 things on top are the same, are equal, are the same thing. How can I make something over 4 equal something different over 4? The only way it's possible is if these 2 things on top are the same thing. So I can almost ignore the 4's completely and just write this thing. Now, I kind of did that before when I turned these into 1s. Dividing by 1 means it's just that thing on top. Or I can multiply both sides by 4 like this, and then the 4's go away right there. No matter what you do, I'm going to avoid cross multiplication, and I'm just going to get straight into n plus 1 equals 1. Okay, I'm getting straight into n plus 1 equals 1. And subtract 1 from both sides, you get n equals 0. So an interesting different variable answer. We haven't really seen that before, but 0 plus 1 is 1, and 1 over 4 equals the same thing as 2 over 8. Yeah, I think that works. Okay. All right. Number 9. Let's smooth through the last bits of these. 8 over 4. What do you think I'm going to do? 2 over 1. Heck, I'm going to write it as 2. Notice I haven't had to cross multiply for a while. I guess this was cross multiplication. But I haven't really had to do that big old bag of tricks for a long time now. X minus 11 over 12. This x minus 11 is dividing by 12. You know, I think a lot of people would probably look to cross multiply here, but keep in mind this grouping is still dividing by 12. So my next step I could ideally just do is multiply both sides by 12. At least it gets rid of my 12 in that denominator, because 12 over 12 is 1. So now I have, and there was nothing else to reduce here, by the way. 12 times 2 is 24, and I have x minus 11 right here. Add 11 to both sides, we get x equals 35. Okay. Nearly done with these proportion aspects that are already set up. Right here, nothing to reduce, so you see right here, but ooh, I don't just look at up and down. I also look at left to right. Look at 6 and 9. I can divide both of those by 3. Literally, I'm dividing both sides of the equation by 3. I can divide both of those by 3, and 6 turns into 2, and 9 turns into 3. This becomes 2/5 and 3 over n plus 11. Okay? Now, I have literally changed the values that were at play here. I have, because I divided both sides by 3. I actually did. But this is allowed. Just like reducing the fraction, this is allowed in a proportion in an equation. Totally cool. Nothing else to reduce at this point, so we do cross multiply. Let's go ahead and get that squared away. Now, this is where, again, n plus 11 is in a grouping. I guess it's the first distribution we get to play with. So this is 2 times n plus 11 equals 5 times, I'll just write 5 times 3 because I have to do another step anyway, equals 5 times 3. Now I have to distribute the 2 into the n and the 11 here. So I have 2n plus 22 equals 15. Just a couple steps away. Subtract 22 from both sides. I get 2n equals negative 7. Divide by 2a, get n equals negative 7 halves, or negative 3.5. I'm good with that answer there. That sounds good to me. All right. So those are 10 questions there, all proportion based. I got 2 more. They're word problems, and those tie-ins with units and stuff will matter a little bit. Again, you might want to look to the video if you have any questions. I have a highlight problem there on heights of things and shadows. But you might make sense of this if you take a look. Set up a proportion to solve each problem. Leave proper units in each answer. This time you're being asked to set up a proportion. Now, it says to solve each problem, which means don't set a proportion and just solve a problem on your own. So I will set this up whether or not the answer is obvious. Here we go. Julio bought 2 bags of radishes for $4. How many bags of radishes can Carlos buy if he has 36? So these are 2 different people. We're assuming, I guess, it's the same grocery store or something. Or market, fresh produce place. It's that there's something needs to be consistent. You can't buy 2 bags of radishes here and another, whatever, pay $36 worth of however many bags somewhere else. The point is that we want to be consistent. So the idea of setting these things up, and again, I don't want to get too deep into it, did it in the lecture video, is that you need to make sure that units and ideas fall in correspondence, they align and fall the same direction. In other words, the 2 bags of radishes for $4, I think it's a good idea that we set up a ratio of just this right here. 2 bags for $4. 2 bags for $4. Okay, see if that idea makes sense. Now on this side of the proportion, what I have to make sure is that on this side I have bags on top and dollars on bottom for the other thing that looks like it's larger. $36 on this side for an unknown number of bags. We don't know how many bags of radishes give us it. And I know a lot of people want to shout out the answer at this time, but this is still something that speaks to the fact that you got to know how this sets up before anything else plays with it. So this is what Julio did. 2 bags for $4 is what Carlos would do here. You can set up the proportion the other way. You can do $4 per 2 bags, and you can find out, hey, that's $2 per bag. And that's kind of what I'm going to write here. I'm going to reduce this fraction. Let's write it out without the units now that we know that everything lines up. I have 2 over 4 equals x over 36. There, that looks a little better. But when you find your final answer, make sure that you leave proper units in it. Our final answer needs to be in bags, maybe as a sentence. Carlos can buy blank blank bags for $36. That's what I would do. 2 over 4 reduces to 1/2. I like that idea. Before I cross multiply, what might I do? Reduce these two. 2 and 36, divide both by 2. That becomes 1 over here and 18 right here. See if that starts to make sense, because I could have rewritten this as a different proportion and fraction, and that would have been fine. Okay, so I have 1 over 1, or 1, equals x over 18. X divided by 18 equals 1. A number divided by 18 equals 1. That number must have been 18. Multiply 18 by both sides. Boom. X equals 18. So what does that tell us? Carlos can buy 18 bags of radishes for $36. Assuming this rate stays the same. That's the whole idea of proportionality. We maintain a rate, and we grow or shrink the set of items, and how do things change? That's all it is. Last one. Then we're all done. A painting is 33 inches tall and 11 inches wide. Let's go ahead and get an idea of a drawing there. Painting, some sort of figure, whatever. Ooh, hey guys, let's party. All right, this painting is 33 inches tall and 11 inches wide. If it is reduced to a width of 1 inch, then how tall will it be? This kind of does a nice segue for me into what's called, it's called proportions, but what's called similarity. And what the idea is, let's say you have the same painting, but you say, can I get a smaller scale version of this painting? Like the same exact painting, same proportions, meaning it doesn't become fatter or something, but it's just shrunk. So I can literally do that on this thing with this tool. I can take one and I can shrink it. I can shrink, and take a look. This is what proportionality means. That all things remain the same when it comes to, the ideas. In other words, how many times smaller did it get in terms of width? It's going to get that many times smaller in terms of height. It's going to get that much smaller in terms of its smile length. Everything gets that many times smaller. So what we're looking at here is one painting that's 11 inches wide, 33 inches tall. This other painting is 1 inch wide, and we don't know how many inches tall it is right here. You probably know by now, but we got to set up the proportion, and this is where things work out again, where you can correspond things in a certain way. I can do width of big to width of small, like 11 inches over 1 inch. Those are the widths, equals height of big to height of small. 33 inches over an unknown amount of inches, that's height. You don't have to do it that way, though. You can instead do, You can instead do width to height in one of your shapes, and then width to height in another one of your shapes. I could have done the width of the big to the height of the big. I'm not going to write units here. Equals the width of the small to height of the small. It's all about correspondence. It's all about writing things that go in the same direction. You might say these are different fractions. Notice how this one is 11 over 1 equals 33 over x. But they're also not. Because you can still reduce things the same way. And look, when you cross multiply, what happens? X multiplies with 11, 33 multiplies with 1. X multiplies with 11, 33 multiplies with 1. It's no different. It's just a different way that I wrote parts in correspondence, but they still do correspond, and that's the point. Now I'm going to reduce this. Let's just do this one. I'm going to reduce 11 over 33 to 1/3. So 1 over 3 equals 1 over x. Well, I don't have to cross multiply anymore. 1 over 3 equals 1 over 3. That's the only thing that could work here. Apparently x equals 3. Now does that answer the question? How tall will it be? How tall will the reduced painting be? The reduced painting will be 3 inches tall. There we go. You get a word problem, you write a word answer. All right, so that's it for these problems right here. I want to cut that one off. I'm at 25 minutes now, so I think that's a good time to kill it. But looking back at the idea again, cross multiplication can happen, but I'll reduce fractions first. I find little nitty-gritty tips and tricks along the way to reduce across as well. That's totally cool. If you're dividing by something, just multiply both sides by the number. A lot of interesting things you could do. I still don't know the score of this game, by the way. Maybe you've been paying more attention to it than I have. But anyway, I'm done with this video here. If you have more questions, just leave those questions in the comments section below, or find some other way to kind of hit me up with that. I'll be glad to give you more content as we go throughout the year. And happy trails, guys. Thanks for watching.